Hello and welcome to the Math League Media YouTube channel. My name is Ian and today we're going to be going over sprint number 29 from our 12517 release. Sprint number 29 reads 4 unit squares are packed into a regular triangular pyramid such that each sphere is tangent to 3 sides of the pyramid and externally tangent to the 3 other spheres. The edge length of the pyramid can be expressed in the form a plus root b for positive integers a and b. What is a plus b? And first of all, let's go ahead and draw this out so that we have a better visual on what this problem entails. So let's go ahead and draw ourselves this pyramid, and I'm going to put that over to the side so that we can more easily access the center of this pyramid for reasons that you will see in a moment. And let's put the center of the pyramid O right here. Now, because drawing in a 3D fashion on a 2D board is always going to be a little bit difficult, let's also give ourselves a 2D visual on what this is going to look like. And let's go ahead and call the face that we look at F. Then we have our center of the pyramid O. Let's also draw a point B on face F that is as close as possible to O. So that'll be right here in our 2D representation. Additionally, let's go ahead and draw in one of the spheres. We can draw that better. And let's call the center of that sphere A. And let's call the vertex of the pyramid closest to A, P. So this here will be P. Then first of all, notice that O, A, and P are collinear, or that A lies along OP by the symmetry of our regular triangular pyramid. Then let's go ahead and draw in the lines, or the line segments OB and PB. And we can draw in PB on our 2D shape as well. And then let's draw in 2 additional points. Let's draw in point C on OB such that AC and OB are perpendicular. And let's draw in point D on PB, which we're going to see better here, such that AD and PB are perpendicular. Now, we can proceed by finding similar triangles and pyramids, and let's start by first computing the length of segment OC. So first of all, let's not draw in all 4 of the spheres, but let's represent their centers. Let's call the centers of the 2 spheres that are tangent to our face F, X, and Y. They don't have to be in exactly the correct place because we're not going to be drawing them in totally. And let's call the center of the non-tangent sphere Z. Then notice again by symmetry that the pyramid AXYZ is also going to be a regular triangular pyramid. That because these spheres are unit spheres tangent to one another, the side length of pyramid AXYZ is 2, or the edge length, sorry, not the side length. And that O is going to be the center of pyramid AXYZ as well. Additionally, notice that A, X, and Y are all a unit above the face of our face F. So they all lie along the same plane parallel to face F. And C also lies at that height because C is part of a little rectangle formed CBDA. So C is going to fall in that same plane. And because, again, of symmetry, C is going to be the centroid of our triangle AXY. Then we have an equilateral triangle AXY with side length 2 and centroid C. So we know that AC is going to equal 2 root 3 over 3. And then by the Pythagorean theorem, we can find that the length CZ comes out to 2 root 6 over 3. Then now let OA be equal to x, length x. First of all, again, by symmetry, notice that OZ is also going to be length x. And that since OC is going to be CZ minus OZ, that OC equals 2 root 6 over 3 minus x. Then, once again, applying the Pythagorean theorem, this time to triangle OAC, we find that x, or OA, is equal to root 6 over 2, and thus that OC is equal to root 6 over 6. Then, by similarity, the large pyramid and pyramid AXYZ are going to be similar, and specifically the large pyramid is going to be pyramid AXYZ scaled up by a factor of OB over OC, which are corresponding segments. And we know that BC and AD both equal 1, and that's the distance from the center of one of our spheres to the tangent point against the face of one of our large pyramids. This means that we also know that the edge length of the original pyramid is going to be 1 plus OC over OC times the edge length of AXYZ, which we know is 2. And since we know that OC equals root 6 over 6, the edge length then becomes 2 plus 1 plus, or 2 times the fraction 1 plus 6 root 6 over 6 root 6, which simplifies to 2 times root 6 plus 1, or 2 root 6 plus 2. And recall that our question asked us to express the edge length of the pyramid in the form a plus root b for positive integers a and b. So converting our answer into this form, we find that the edge length is 2 plus the square root of 24. So a is 2, b is 24, and a plus b equals 26, which is our answer. Thank you very much for watching, and we'll see you in the next one.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.